me. I'm part of BCU crowd. I'm a member of staff there, and I also am involved in recruitment, and I also do teaching at undergraduate and MSc level. I have been taking part in this program previously. 2 years ago we did it at Netherlands. Last year we did it at our place. Was anyone, apart from my lot, anybody else involved in it? You lot got to like. So you've been to Birmingham. So bear with me when I show you the slides of Birmingham. Okay, so 2 years ago when we did this presentation, all the staff sort of started a trend and said, right, we're going to introduce our university first before we talk about the subject. So I'm going to keep up that trend because I noticed Rob started that on Monday. So he talked about the Netherlands, and I'm going to start off with a bit of that as well. So what I'm going to talk about is a network that we use in the UK. It's called the N3 network, and it connects all the hospitals together, it connects all the GPs together, it connects all the pharmacies together. It's a huge network, and we use that in the UK. So what I'm going to do is I'm going to tell you a little bit about the N3 network and how glorious it is. But then it does have some issues which nobody talks about. So I'm going to come up with a couple of issues and a little bit of a solution to it. I won't go into the solutions of it too much because you need to know command line configuration, you need to know IOS, and it's a subject area on its own. So I'll just sort of finish off with what the solutions are. So my name is Chaz. I don't know if you've seen me around. Okay, Chaz. Not BCU. Okay, so this is the contents of my presentation. I'm going to talk about BCU first and where we are in the UK, and then give you an overview of N3 and the issues and what causes these issues. So I've listed a couple of issues defined there. So they're to do with voice, video and data, and a solution how we use to solve these issues. So those who haven't been to Birmingham before, this is our building on the right hand side. It's Millennium Point, this is where we are. We're right in the city centre, and on the left hand side you see a development phase. This is what's happening now at Birmingham. So, okay, this part here is this building here. Okay, that's already built, and then we're in the phase of building this area here. This is already built. I think UK2 did a presentation on the bin module. It was based on that building. So those who don't know UK, we are right in the middle, miles away from any seaside, unlike you.
Miles away from the rest also.
So it takes roughly about 2 hours, I would say, to travel from there to the capital down in London. So we're in the middle of nowhere, but we have got lines that come into Birmingham and out of Birmingham. So it's quite centrally located. That's where we are. This is the development phase, and this is Millennium Point at the top where we are. This is our Parkside building that they did a bin model on. This is currently being built, so I'll quickly flick through it. That's Millennium Point. Phase 1 is already built and running. Phase 2 is being built, and in fact it's the same contractors who built phase 1 that are building phase 2, and because of the problems they encountered in phase 1, they know how to build phase 2, so they're working at a faster rate, so it should be delivered before the contract is supposed to finish. HS2 is the high-speed link, which is a super duper high-speed link. I think you've already got them in Europe that connect your cities. It's supposed to take you to London in 40 minutes. So completion for that is 2026. We're not very far from the town centre. In fact, you can walk to town centre, have lunch, come back and get into your lecture at 2 o'clock. So there's Moore Street Station, and then we got New Street. These are some pictures of Birmingham. Pretty nice city. It's a multicultural city. Walking distance from Millennium Point. This is Birmingham at night, the town centre. Pretty impressive. It's a nice student area as well, where people go for drinks. You've been there. I think some of the guys have been there. This is town centre in the summer. It's very dull at the moment. I don't know what the weather is like, but it's pretty nice. This is our Roman building. This is our town centre. This is a new shopping centre that's just come up. It's supposed to be state of the art. Selfridge is at the bottom. It's got 4 floors of shopping centre. It's just a shopping mall. Escalators right here and there. Some of the pictures at night. Lots of canals in Birmingham Town Centre. Lots of student life. Lots of restaurants on the side. Some of the buildings of BCU. This is the Parkside building that's already built. State-of-the-art building, as UK2 listed it. So some of the pictures around from our section Millennium Point and Parkside. Okay, let's start with N3 networks. Okay, N3 networks are a huge network that links all the hospitals together. So let's have a look at an overview. This is the structure of an N3 network. You can see it has a core and it has lots of pops. You can see this is Scotland, this is the top part of the UK. Then you have the bottom part, you have a pop for all the England hospitals. God knows how many hospitals there are in England and Scotland. You have facilities for remote access, so people who are working in hospitals or GPs can actually log in to this network and extract all the patient data if they wanted. They can work from home. That's the idea of this N3 network. You can see it's connected to something called Janet. I don't know how things work in Europe, but the universities have their own network as well, and that's called Janet. The police have their own network. God knows what that's called. But you can see all the services have their different networks. And then all these networks are connected to the internet, to the outside world. So this network was provided by somebody called BT, British Telecom. Is a huge ISP company, and they give you all the services. But there are many ISPs in Birmingham. There's Sky, who provide you with broadband connections. There's Virgin, there's TalkTalk, there's so many. But BT is one of the biggest ones. So they are the ones who are managing this N3 network. Okay, so what are some of the facts about N3 networks? It's a network for our professional healthcare people, like hospitals. And the reason they created this network is to give them quick access to information from anywhere, easily and at any time. So it ensures that the patients get the best possible care whenever they need it. It's one of the largest virtual private networks that you'll find in the UK and Europe. So the picture on the right hand side says it's got 51,000 connections. That's how big this particular network is. Okay. Looking at Europe, England, Ireland, we have about 1.3 million people working in the National Health Service. So all these people rely on this network. That's how many people this N3 network caters for. To give you an idea of how big this network is, Manchester was in the middle of that picture I showed you. Nottingham was slightly on the right. These are big cities in the UK. Bristol and Aberdeen also is a big city. And the population combined together is the equivalent of 1.3 million people who are using this network. So that's an absolutely huge network. Comparing that to BCU, we have 25,000 students, and that network is considered big, 25,000 students, but compare that to N3, this is 1.3 million staff using this network. Okay, when BT laid the cables on this particular network, they said they used enough fibre optic cable to span from London to San Francisco and back again. That's how much cable they had to put in to make this network work. That's absolutely a huge amount of fibre optic cable. It is just more than a broadband network. It's not just about accessing data. This network is also used to provide every staff member access to a VoIP system. VoIP meaning, when you go to a bank these days, when you go to most large organizations, they have a VoIP phone. So it's using the N3 network to make calls between organizations. BT also provide access to your mobile phone network. So what they've done is they said, well, if you use your N3 network and you use the N3 network to call a mobile phone, we'll give you some discount. So they give them 30% discount on call charges. So not only were your phone calls free between organizations if you made a call within the N3 network, you had a discount on your mobile phones. So this reduced the NHS's bill by £4 million. That's a hell of a lot of money. So there was a big saving there. So it was used for your patient data, your data networks, web browsing. It was used for IP networks, voice over IP. It also was used, it is still used for video conferencing. So the idea of video conferencing is, you've all must have done some sort of conferencing where you link up with maybe another classroom. Since the network was gone up, they say they've done 48,000 sort of video conferencing meetings since this network has gone up. So the idea was, staff didn't have to now travel from one hospital to another. So this reduced their travel costs. So in terms of the amount of travel costs, or in terms of the amount of fuel they saved because they didn't have to travel, it came to about 2,100 tons of fuel savings. That sounds a huge saving to me. So the potential savings with all the other savings comes to about £100 million. So I thought I'd link that value to sustainability, because 2,100 tons of fuel is a hell of a lot of savings. They also lowered the emissions. So the slide says it supports 20,000 virtual private networks. This enabled staff who were commuting to work from home. So the idea was, they can't work from home all the time. So within a week, they came up and said, right, staff can work from home for 1 day a week. So adding that to the 1.3 million staff who were using the network, they estimated that they were saving 150,000 days of commuting. So we have a director in NHS who is what we call a sustainability person, looks at how much savings they do in terms of CO2, and he said that if staff were working from home for just 1 day a week, that saved 1,000 days of commuting, that was the equivalent, he worked out, to be 1,250 tons of CO2 emission savings. So I thought I'd relate that to sustainability. Okay, glorified network, I said how good it is, how much savings you do with this particular network. When you try and read about it on the internet, nobody talks about any issues with the N3 network. Any networks have issues. I mean, we've been using the networks here. It keeps going up and down. I don't know if anybody else has noticed it. There's some issues.
Let's take the network of the hostel.
We don't get it in BCU, by the way. But our network does go up and down at BCU as well, but not as often as here. Sorry, guys. Okay. What I wanted to say was, what are the issues and why are they caused? We had an open day last week, and I was chatting to a lady who works in a hospital who brought her son, who was going to be a student starting September 2015, and I sat down and I said I was going to do this presentation about what do you know about N3 networks. Oh, she goes, Chaz, don't ask. It's a pain. And she works in a hospital, and I can understand. We've got a great network at BCU, but it's still a pain. It never works 100% perfect. You have the same problems, but why do you have these problems when the network is supposed to be fiber optic links? You're supposed to have so much bandwidth, and why do you get these problems? So I came up with a couple of suggestions that these days you have many applications. You have VoIP, you have video conferencing, you have your data, you have HTTP, FTP. All these applications are running on the N3 network, are running in your university here, are running in our university over there. And each application requires a different delivery requirement. So in terms of how long it takes to send data from one machine to another, or how long it takes when you lift the phone to make a conversation with, and what's the delay between these two. That's what I mean with delivery requirements. And some applications are critical, and some it doesn't matter. So before the N3 network came out, the hospitals were connected via separate lines. So here, this diagram here shows that there's a phone jack. You all remember the times when we had the old phones, we picked up the phone, we dialed. That was a separate line. It connected to, in our case, BT, where you had that lady sitting at the panel, took out the cable and connected from one point to another. Do you remember that? And that was a dedicated line that connected.
It's before your time.
It probably is. So that was a dedicated line the lady gave you from your point to another distance point. You had a line. If you were using computers, then you had a dedicated line for that. If you were using video conferencing, they came in and put a camera in, and they put a box on the wall, and they give you a line to your distance location. So you basically had 3 lines there. So there were separate networks, and there was no problems. So you're going to say, oh, Chaz, they put an N3 network in and caused problems. And that's what they did. There was no problem previously. But you're going to say, why did they do that? These separate lines were costing them a lot of money. So what they did was they combined these 3 lines into what we call a multi-service network. And the word they use for a multi-service network is converged networks. Have you heard of that before? So everything now is converged into a data network. And because everything is converged into a data network, this is where the problems come. Okay, so many of the applications use something called best effort. You're going to say, what is best effort, Chaz? You know, when you're using your application, you're using your iPads and everything, your web browsing, these use best effort systems. So you don't worry about how slow the network is, because if you're going to browse a network, or you're going to send an email, you write your email, 7-page email, and you press send, but you don't really think how long it takes to get to its destination. But you don't really care, because you know it will get there. It's like putting a letter in the post, just with the stamp. In the UK, you just go and post it, and you know that your letter will get to its destination. But you don't know when it's going to get there, but you do know it's going to get there. That's what we call a best effort system. So for many applications in the technologies that we use today, file and print systems, internet browsing, email, these use best effort systems, no problem. Okay? But you need to now start thinking of applications that it does matter to decide on how long it's going to get there. And these sort of applications are VoIP or real-time applications. And this is where quality of service comes into the network. So you have to apply quality of service. What is quality of service? Quality of service is the ability of the network to provide an improved service for selected network traffic, not all of it. Okay? And it says that you don't really care what cables you use, whether it's fiber optic, whether it's Ethernet. You don't really care about how you get, what cables or hardware you use. But you select your traffic, and you make sure that that gets dedicated paths. So the diagram at the top shows here, you can just see the ambulance on the top. The projector needs to come down a bit. In the UK, we have a lane which is called the hard shoulder, and nobody ever uses that lane unless it's an emergency. But emergency vehicles can use that lane anytime. So what this slide is trying to show you is that a selected type of traffic, in this case the ambulance or the fire service or the police, will use that lane to get from one point to the other. So reducing delay, and that's quality of bandwidth, quality of service. So quality of service is saying, right, let's take some traffic and give it dedicated bandwidth. So in this case, the ambulance gets dedicated bandwidth. Because you've given it dedicated bandwidth, you've also improved on what we call the loss characteristic. Okay, meaning that if the ambulance was sort of using that particular area, if, for example, there was an accident, there's going to be loss. It means the ambulance is not going to get to its destination because of an accident. So by giving it dedicated bandwidth, you've improved the loss. The bottom are just sort of queuing techniques, which I'm not going to go into, but these are techniques to improve your services. So what defines the goal, the movement of this traffic? There's three things that you have to look at. They are loss, delay, and jitter. Okay, jitter is something called delay variations. So in the next few slides, I'm just going to look at these in a little bit more detail. These are the things you need to look at to improve the quality of service in your network. These are the things that the N3 networks are probably looking at, but you don't hear about. on your websites. Okay, so what is loss in terms of applications? So let's say this guy on the left-hand side is sending an email to the lady on the right-hand side. He writes an email, he puts it through the network, and for some reason, something happened, and he's lost one of his characters. So he's saying hi, Susa, and on the other side, he's lost the S in the network. That is loss. What I'm trying to say is when you hit return, you're sending an email, it goes through your network, some of the packets might be lost. Okay? And you're going to say, Chaz, but my friend always gets the whole complete email. Okay, so there's techniques where they use in networks where if a loss occurs, applications resend the data. And those people who have done networks will know that those are called TCP applications. Okay? So with TCP applications, things like email, things like web browsing, FTP, if you do get lost, these lost packets get retransmitted. It's not a problem. So how does loss occur? I say errors in the network, I say corrupt firms, I say congested networks. So how do you get errors in the network? Let's take Millennium Point at our university as an example. Okay, so when they built that building, all the cables run down the corridors. So you look on the top, there's no ceilings, it's just sort of metal. So you look at the ceiling, and on the side you've got the mains cabling. On the right hand side you've got the data cabling. They're running side by side. So what does that cause? You've heard of the word interference? Yeah? So if I was to go and switch off and switch on the light, what do these lights give out? Electromagnetic interference. These lights are they're constructed with transformers, and they give you glitches. If I had some sort of meter and I stood there and I was picking up these electromagnetic fields, somebody switched it off, I'll get glitches. Those glitches go into the cables. So if that cable is carrying my data, I would get an error. It would corrupt my frame. And when that frame gets to its destination, it's a corrupt frame. And the destination machine will read that frame and say, oh, I can't read this, and drop it. You get lost. That's just one way. In the early days, you were making networking cables, Ethernet cables, and I remember students, I would say, here's the cable, here's the plug, make me a nice little cable. And they used to say, Chaz, here. And I look at it and I say, is this a networking cable? Because they used to strip the whole thing. They used to untwist all the cables and put it into the socket and crimp it. That day, at that time, you do get errors. But nowadays, you don't do that because your connections, your cables are so cheap to buy, and they're such good quality that you don't get errors in the network due to hardware. You do get loss due to congested networks. So if I was sending a VoIP packet, or I was making a call and I got stuck behind an FTP transfer, that's called a congested network. My VoIP packet has to get to its destination within a certain amount of time, but I've hit congestion. And if you hit congestion, your packets get dropped. They can only stay in buffers for a certain amount of time. So that's a little bit about loss. And I have put a little bullet point there. I said that loss is becoming very, very rare because the hardware they make, the cables they make, you don't get interference in fiber optic cables nowadays. And everything is going in that direction. So loss is becoming very, very rare. I said a little bit about TCP and UDP. Email, HTTP, FTP, they use TCP applications. So the idea is if you do get loss in this, maybe they got stuck behind some traffic and the network then started dropping packets. These applications, I'm not going to go into how they work, don't receive an acknowledgement. So your source is sending this information, won't get an acknowledgement saying it's got to the destination. And because it doesn't receive an acknowledgement, you resend the data. So loss doesn't matter with TCP sort of applications. But loss is very important when it comes to real-time traffic. These days, what uses real-time? Skype, FaceTime, your VoIP phones, these all use real-time traffic. Okay? So with real-time traffic, real-time traffic normally uses UDP. And the idea is, when you send real-time traffic, you don't know whether it's got to the destination, you don't get an acknowledgement back, so you don't know that if there's a loss. You don't know if your traffic has been dropped, so you don't know whether to resend, and you don't normally repeat your conversation, do you? You're going to say, yes, my Skype connection's always bad. So, losses are less tolerable in UDP traffic. Okay, so this is a little guide. They say when a network is highly available, it should suffer 1% or less loss. That's a highly available network. Can you see? That's a very small figure. I'm saying that when you send 100 voice packets, you can only lose one of them. That's a highly available network. And it should really approach 0 to make it absolutely 100%. Okay? So what's the other thing that causes problems? The other thing is delay. So why do you get delayed? Let's say I have to travel from Birmingham to London. Okay? Now I have to travel that distance. It takes time to travel that distance if I was using a car. It's exactly the same in networks. You've got a packet that comes out of your source, whatever device you're using, it's got to travel down that cable. And that cable will have delay. The longer the cable, the longer the delay. So delay is caused for many reasons. It's the time the packet takes from the source to the destination. That's the delay. And there are many, many reasons why you can get delay in a network. Okay, delays consist of what we call fixed delays. This is what we call serialization and encoding. So without going into too much detail, your packet is going to hit an intermediate device. Okay, it might be a router, it might be a switch or whatever. And that thing is got to make a decision on where to send the packet. That thing consists of a fixed delay. It takes time to read that packet. Comes in on an interface, it's got to go out on an interface. There's a little bit of delay there. That takes time. It doesn't just go straight through. You have to read the packet. Or delays can consist of something called variable delays, and this is the result of congestion. Okay? If you go out at peak times, I don't know, I haven't seen any traffic in Finland. Do you get congestion in Finland? I haven't, you do? Finnish guys are saying that. If you go peak time to London, it could take you up to 4 hours to get there. Double the time. So if you hit congestion, that's how long it is. And packets are the same. It works the same. If you hit a line that's got congestion, your packet is going to get stuck behind it. And that's going to cause delay. And delay in networks is very important, especially if you're using VoIP. Doesn't matter if you're using TCP application, but if you're using UDP types of application, then there will be a problem. And this is problems that you don't see in N3 networks. They don't discuss this, but it is an issue. So, as a design rule, if you're using real-time traffic or VoIP type of applications or video conferencing, they say that your packet has to be delivered across the network within 150 milliseconds. So, if I'm talking to someone on the phone from Birmingham to London, that's a big distance. My packet has to go from my source to my destination within 150 milliseconds. And that is that sort of delay. That's a very, very small delay. If you exceed that, then your quality of service is not there. Okay? That's a minute time. You've got to realize that. Okay. The other thing you have to worry about is jitter. You're going to say, what is jitter? Jitter is what we call delay variation. So, if I'm talking on the phone to my destination partner in London, what I'm doing is I'm sending a constant stream of voice packets. Okay? Now, if some of them voice packets hit congestion, some are going to get there before, some are going to get there later, but they'll all eventually get there. And the time difference between the packets is something called jitter. Okay, and you can only have a certain amount of jitter in networks. So there are mechanisms to reduce jitter in networks. These mechanisms are called buffering. So I'm not going to go into buffering, but I always think of buffering as like a bucket of water with a tiny hole. And when you fill it up with a jug, it's dripping out at a steady pace. Okay, instead of having a big hole where it rushes out, and then you've got a gap, and then you fill it in and you've got a gap. Do you see? That's how I always relate to a jitter buffer. So you must have a minimum amount of jitter, and they say, I'm not going to show you how to calculate jitter, but you can't exceed 30 milliseconds. If you exceed 30 milliseconds of jitter, then they say your quality is going to go down. Your voice quality is going to go down. And if you're using VoIP or video environments, what you're going to get is jerky motion, you're going to get loss of video, you're going to get loss of... you know, when you're using satellite TV, you ever seen little blobs come on the screen? And you get a little bit of loss there. You might lock up sometimes, that kind of effect. Okay, so how do you make sure that all these things never happen? You make sure your network is available first. Because you come here, the first thing you do is log on. And if you can't log on, it's because your network is not there. Okay, so there are techniques in networking where you make your network available. And the diagram here shows that you use duplication, or the word they use is redundancy. Okay, so make double of everything, and it costs a lot of money. But the idea is, if you're using a VoIP phone over here, and your ISP goes down, your router to the ISP goes down, then what happens is you use dynamic routing protocols, which I'm not going to go into, to change the path to another path. So this all happens automatically. provided you've got redundancy. If you haven't, you're in trouble. Okay. To stop congestion happening, what do you do? If I wanted to stop congestion from Birmingham to London, what would I do? In terms of cars and lorries, we've got a 3-lane motorway there.
Use a Ferrari.
Make it 6. You make it 6. 6 lanes to London will stop congestion. Okay, you can do that with networking. You can go to your boss and say, your boss will come to you and say, oh, I've got a problem. I'm fed up with this phone. Keeps locking up on me, and you say, I'm the technician, I'll fix it for you. He goes, go ahead. And you go away and you go to your ISP and you say, how much bandwidth have you got? And he goes, you've got 1 meg. He goes, give me 3 meg. So you bought 3 meg of bandwidth, and that is like doubling the lanes on a motorway. And you go to your boss and you say, use the phone. And he picks you up and he goes, how are you? You've done well. What did you do? And he goes, I fixed the problem. And then a month later he gets the bill. So if he was paying £100, he's paying triple the amount now. And that's where he gets the sack. So you can double the bandwidth, but it will cost you an arm and a leg. That's what we call over-provisioning. Okay? For the amount of traffic you got that you want to send down the network, you can over-provision by the bandwidth, but it will cost you an arm and a leg. Or, that's called over-provisioning. But you've got to remember with queuing, this technique, you've got to have enough bandwidth to carry the amount of traffic. If you don't have the bandwidth, there's nothing you can do with queuing to fix your problem. You can't send 20 cars down a cycle path. You're always going to get delays. You're always going to get problems. Do you see what we're trying to get here? You always have to have the right amount of bandwidth, but the way you manage that bandwidth using queuing techniques might be better than just buying a 6-lane motorway. Does that make sense? So you always got to have the right amount, but the way you manage it, that's how you make your network more efficient. Okay. 15 minutes. Okay. So here we've got different applications using different, and it's just a summary of what I've done. They're all looking at delay loss and jitter. So in terms of quality of service requirements for data, when you're configuring quality of service requirements, you need to look at all the data and you need to put them into classes. So here, what you do is you have a gold class, you have a silver class, you have a bronze and a less than best effort system. So if you say accessing patient data is very, very important, then you would put it in the gold class. And the gold class says, if I hit a router, that's the traffic that's going to go out first. Okay, so in terms of networking, you have lots of data types. You need to recognize which data type goes into which class. So in terms of data, you have gold, silver, bronze, and less than best effort. The bronze type there says you will put internet traffic, email traffic into that. That's of less priority than gold. So when it hits the intermediate router, it will take it as less than best effort priority. So it will send it after the best effort priority. For video, all the video quality is affected by loss, delay, and jitter. So when you pick up a phone and you're using your VoIP, they say that if you do get lost, some of your packets can get lost. Normally, it doesn't matter, because on the other end, if there was a loss of 30 milliseconds of voice, the human ear would put the voice together and you won't really recognize there was a loss. Okay, so you can tolerate a little bit. That's that 1% of loss. So you could tolerate a little bit of loss, but if this loss becomes heavy and you lose a lot of void packets, then that's where the other end is going to start sounding like that. Okay? You're going to get delay in between. So if you lose 2 consecutive packets, that's like 60 milliseconds of jitter, and that's no go. You've gone past the 1% barrier. The other thing to worry about is delay. So your voice packet has to be delivered from one end to the other within 150 milliseconds. Okay, quality of service requirements for voice. You can be more lenient with that. I'm looking at YouTube videos here now. You've got streaming video. These are using TCP sort of applications. So when you download a video on YouTube and you want to watch it, normally when you play it plays well, doesn't it? Sometimes it locks up while you're playing. But once it's downloaded, because it comes down as a stream, it uses TCP. So they're more lenient with that. So YouTube is like, you can say it's like FTP. So when you're downloading a YouTube video, it's like downloading a whole stream, and it can impact on the network if you're using VoIP as well. So with this, this is a video conferencing. This is similar requirements to VoIP. Okay, so very strict. You should have loss less than 1%, and your jitter should be less than 30 seconds, and your video application needs to be delivered within the 150, they say 200 milliseconds time. Okay, and you get sort of a better quality. Okay. Just a few minutes, I'm just going to finish off with some of the solutions you can implement. But each of these solutions are a subject area on its own. So if I was to implement one of them, it would take me a week to explain to you of how we go about doing it. And I want to stay away from configuration because I know some of you haven't done iOS, some of you haven't done networks, and some have. So I've tried to stay away from. So I'll give you an overview solution of how we cater for these problems. Okay, we use basically 3 models to implement queuing and to cure some of these problems that we have. These are areas that are being implemented in most networks. The most popular one of these is the differentiated services model. Okay, the first one is the most easiest. It's what we call the best effort model of applying quality of service. And that method is my best method because with that method you don't need to know anything. You go in there, you set up your network, and you rely on the network to decide on which traffic is going to go first. So it works on what we call a first come, first served basis. So if I was using FTP and I was using a VoIP phone, whatever hit the router first, if my FTP traffic went first, it would be the first one that would be sent out. That's what we call the best effort system. By default, that's what they are. And if my VoIP packet was behind, that will go after. Can you see a problem with that? What's the problem? FTP packets are normally large. VoIP packets are normally small. Okay, FTP packets use TCP and VoIP use UDP. So that VoIP packet has to be delivered to its destination within that 150 millisecond time. So if I get stuck behind an FTP, a router sending a large packet, can you see that's going to add delay? You're going to exceed that 150 millisecond time interval. That's going to break up your voice. So no good for VoIP applications. Okay, generally very good for everything else. If you don't know how to do queuing, you'll do best effort system. If you're very good at networking, you can use the integrated services model. And this is a great little model, but it hasn't taken off, but it's there. It uses a signaling protocol between your source and your destination. And I'm going to say the word of it, but don't worry about it. It's called the Resource Reservation Protocol. And what it does is reserves bandwidth from your source to your destination. So it's saying that I'm going to send a signal across from my source to the destination, but each device will reserve bandwidth for my VoIP application. So it doesn't matter what the other lot is. It's like that ambulance diagram. You're reserving a lane. So you're sending all your important traffic to that reserved lane. And that's what we call using the integrated model. But that's not how it works. These days we use what we call a differentiated services model. And that's what the internet is built on nowadays. And the idea between this one is that packets are characterized as soon as they hit the router. So when the router receives a packet, it looks at how important that packet is. So if it's hit by FTP, if it's hit by a VoIP packet, it will say, oh, but I've been told that VoIP is more important. I'm going to send you before FTP. So can you see how you reduce the time interval when it's VoIP using the differentiated services model? So each of these, you need to look at the TCP packets and you need to characterize them in your service. You have a type of service field with each of them and you mark the packets. The packets that are marked with high priority will be the ones that are going first. On top of that, you have a lot of queuing techniques. Okay? So I won't go into that because that's another subject area. So if you go to a I don't know if you got it here, but when you go to a busy supermarket in the UK, you have about 30 counters. Is there a supermarket here with 30 counters? A huge supermarket open 24 hours a day. Tesco and Asda, you must have heard it. I hope you have. You've got 30 counters, and believe me, when it's congestion times, you can't get to a counter. There's big queues. So the way they manage the queues, is in a supermarket, is you have a lady with a little sign, and she'll stand outside just before the counters with a little sign, and she'll look at which one's free. So when you look down the lane, you see this little sign. She's holding a little sign saying, "This one's free." You see what she's doing? She's managing the queues, and you get a similar effect happening in intermediate devices. You have queuing techniques, okay, and those manage which packets are going to go out first. Got it? So that's an area I don't want to really go into because you need to know configuration. And I'm going to stop there. So, guys, I tried to use the same character as somebody else. Somebody else used Disney. Have you got any questions, folks?